让我难过。
看一片一片花开花又落，我依然执着地爱着。
在经过浪漫红尘的诱惑，人在那风雨难割舍。我们的爱情就像点点的星火，你无时无刻不在温暖我。
真心的相爱不怕高山来阻隔，有你在身边就快乐。
我们的爱情就像熊熊的烈火，它烧出一幅天亮和地阔。
真心的相爱不怕火海来折磨，我们就是最美的景色。
How to control 9 stations operating together. On the screen you can see 8 robots, 4 Kuka, 4 Fanak, and 1 index table. How to relate these 9 stations working together will show multithread in the later demonstration. First of all, we have to say thanks for Monday's whole day's struggling. We push out a Chinese version website of our company. The PLC mode, if we press the input 1, eight robots will operating according to the input script. After 1 operating, the index table will turn according to the right hand rule 45 degrees from here to here, and so on. Each robot running the same video script according to the teaching process. We just duplicate from P2 until P9 for 8 robots. For 8 robots, the P1 test A is the control the whole system. First of all, P1 test A enable input 2 until input 9 to let it change from 0 to 1. Then supports for input 9 become 1. The P9 test A will be actuated. The 8th robot will operating according to the CC file. After these 8 robots operating to the end, the P1 test A will close the input from 1 to 0 and wait for 12 seconds, and the input 1. So the program will circulate it on and on until press the reset or stop key to force the program finished. For each CC file, we have to control the motion control car as well as the input and output. We'll see how to control by multithread by the program. Right now I'm showing with your C++ 6.0. the program is CAPP KHCMS DSW, and open it. The program is teach status. Teach status 1 is the first station. In our CMS CAPP, the standard is 9 stations. Station 9 is ninth station. The program at the beginning has to announce teach status 1 until teach status 9. Otherwise, you have to put in sequence. You cannot upside down to set the program inside VC++ 6.0. The better way is to announce at the beginning of the file. And then, according to the operation, we set PLC mode and accurated input 1. The program will let input 2 until input 9 to change from 0 to 1. And the 9 stations will operate it all together. The program like this: P9ST equal to 1 is the first station. We open HThread 0 equivalent to use this API CreateThread and announce teach status 1 to write the instructions to control the first station. And here is active 0 to control this thread active or not non-active, and create an ID, thread ID 0. We use array to announce thread ID and active as well as HThread. Then we jump to see the next stations. The next stations P9ST equal to 9. thread 8 equivalent to CreateThread, and here teach status 9, which writing the instructions to control the nice stations. Most important is to control the visual script, the K value, and to control the motion control car, and input-output of PLC by Modbus, and use active 8 to show the station is active or non-active, and give a thread ID 8. Then we direct to see the teach status 1. We write all this program at a real of the whole program. For every teach status, the subroutine is all the same, except the variable. We use array to separate each other. We see teach status 1. D word here, that means we have to return a word as the program finished. You can see here, this one is Win API, is originally defined by Microsoft Win API. The file name teach status 1 is the routine name defined in previous by CreateThread function, a parameter written at real. The local variable integer allows P9STS to differentiate from the main program's P9ST. For the first station control, we set P9STS as a constant 1. For the nice stations, P9STS equivalent to 9, etc. And allows a local variable IU here to be used from 0 until number teach of first station, simply because P9STS equivalent to 1, 1 minus 1, so it's 0, 0, num-teach 0 means the line number of the first station. I times is here. We still has to prepare if the program, if the routine running more than 1. Actually, it always I times equivalent to 1. The run number P9STS minus 1 always be 1. But the program you can set, it could be 10 or some other integer value. the program will run in the script the run number times. And the variable IOM used later. And IO times 1 equivalent to 0. And give a Boolean value AC active 1. Active 1 has the relationship with the input parameter. So we can control the station 1 by outside if we press a stop key. The first stop will become 0, and then this thread could be first to stop. The program using these two lights, these three lights, to control, to communicate with the main program. We have to say these multi-thread functions is follow Gene Adams and his RPG books. We just keep the head and the tail and change the contents in the middle according to the need of our program. So we see the end. If the key pressed to first stop, this parameter becomes 0. Then the program will go to teach stop 1. The program will first to go to the end of this routine, teach stop 1. Then the teach mode 0. 0 means first stations. The teach mode will become 0. The first stop 0. 0 means first stations will first to become 0. If the program automatically finished, then the program will run into teach status 1. And then the first stopped 0 becomes 0. The run mode 0 becomes false. So the main program knows the station 1, no running anymore. And the active 1 becomes false. The active 1 is a flag thread, is no longer active. And most important is these two routines. The first one is exit thread. 0 means station 1. Special code to close the thread. And the second one is closed handle, H thread 0, and then return a D word. 0 means the program running correctly. Okay, let's to see the content written by CMS CAPP. The first line of the content is for I time equal to 0 until I time less than run number P9STS -1. I time plus plus. For this variable is for the arc control, for the middle point. At the original, we let middle mode become false, and the middle X mode become false. That means it's an initial case. The middle point is false, it's not used. If the teaching instructions is bigger than the begin teach instructions number, we can continue the program running. That means the instructions can start it from any position in the middle of the whole file. Don't need to start it from the first beginning line of the control of the whole control instructions. If started from any positions, the program will jump. The IU won't be from 0. It could be suppose 10, 20, or any numbers. We'll go to BG01 and to execute the program not from the beginning. For normally used, the instructions will start it IU equal to 0 until IU lower than number teach P9 STS minus 1 IU plus plus. If first line we meet the first step equal to 0, then the program will cease, no more running anymore. If not meet the first step condition, the teaching record is running first to check if k equal to 29. K equal to 29 means home plus plus. We can use home plus plus in the main program to set any position as the original position. If k not equal to 29, the program will go to else if k equal to 6. K equal to 6 means join mode, first point. If k not 6, the program will go to else if k equal to 42. K equal to 42 is wait for internal input. If not 42, the program will ask if k equal to 32. Wait for IO input. This is the script according to the specification of CMS CAPP. If k not equal to 32, the program will ask if k equal to 33, wait for internal input. Otherwise, the program will ask k equal to 8. K equal to 8 is join mode, the middle point of straight light. If k not equal to 8, then the program will check else if k equal to 20. K equal to 20 is open I/O, and we'll ask k if equal to 21. Close I/O, or k equal to 22. Delay time, or k equal to 30. Change the control station, or k equal to 99. K 99 is the mark to mark the program end. Else to check k equal to 9 or k equal to 11. K equal to 9 and k equal to 11 to show is to handle the middle point, the arc middle point in join mode. The k equal to 11 is the end of the arc. Or the program will check if k equal to 5. K equal to 5 to handle the join mode single point. And then to see if k equal to 10. K equal to 10 is in join mode is the end of a straight light. If for the water jet machine, we'll cross water, cross the sand. For laser machine, we'll cross the laser. If k not equal to 10, the program will continue. Oh, finished checking. And every k be checked. This program is previous written. In here, no more needed, but maybe need to be used later on. We mark it by slash and the start at the first line and the end with the start and the slash. The program will turn the characters as green. Later on, we cancel this mark and the first line mark. The program colors will change back to black. At the end of the program, we give a sleep delay a space-time for stable control. Okay, we talked already. The control, including the I/O control by Modbus, as well as by motion control. We use an example for k equal to 8 for the straight light. Okay, here, k equal to 8, the middle point of straight light. In here, we use MCC set feed speed. MCC is ITRI's motion control API. Set feed speed, that means we'll go a straight line. How about the feed? This line to define the feed speed with two parameters. The first parameter is the feed speed. MMPS is millimeter per second, not millimeter per minute. It's millimeter per second. And the group index. The group index defined according to the motion controls specification. Actually, for LOBA, for 6 joints LOBAs, we need only one motion control car. The group index only one. But for A robots, then the group index could be started from 0. For 9 stations, a group index could be started from 0 until 8, simply because this is station status, teacher status 1. So in here, group index P9STX-1 is 0. For the teacher status 9, group index P9STS-1 is 8. After the speed definition, the straight lines, we use MCC line to announce where to go, to specify the position of X, Y, Z, U, V, W. Six axis. This program is written according to ITRI's 6-axis motion control car. We have to follow its specification. The first argument is X, the second is Y, the third is Z, then U, V, W. And group index P9STX-1 in here is 0 for first car. And actual axis X, actual axis Y, actual axis Z, X, Y, Z, U, V, W, we have to write at the rear. After these two lights throughout into ITRI's motion controls continuous buffer, the program will keep running. Then we use MCC get commands to see how many instructions inside the video buffer, and sleep for 100 microseconds, we will see the early turns. If equal to 0 means the motion control car running okay. Then we check the CM count. CM count is the value to count the number of instructions remain in the continuous buffer of ITRI's motion control car, because the program we defined the continuous buffer with 10,000 instructions. We check if the remain count bigger than 9,000 instructions. Then we go back to check again. Not really continue input instructions into the continuous buffer to avoid overload of the continuous buffer. Okay, this is for motion example. For I/O, in here, if k equal to 20 means open I/O. Open I/O, sometimes we doing some clip or some change the program. So in here, if we check the current instructions k equal to 20, we use teach wait 1. Teach wait 1 is the delay routine for station 1. Teach wait 2 is the delay routine for second stations. Teach wait 9 is for postpone the ninth stations, etc. After wait 1 finished, the continuous buffer inside the motion structures will be consumed be 0. The continuous buffer becomes 0. Then the program will continue to go this line. Nothing after the teach wait 1. No instructions at all inside the continuous buffer. Then the program asks if the teach record Y according to the script, we use XYZ to represent different meaning. This program is handling Y equal to 0 and Z equal to 0. Then we check the input X. We check from input 1 until input 44. If X input means input equal to IOM, as an index, then we late input. Suppose if X equal to 2 for P2, for second station, then DIM index 2 equal to 1. DIML become 2 equal to 1. The input input 2 value changed from 0 to 1. Then P2 test 8.cc will be activated because we used the K20 OpenIO to let this opened. You see IOM from 1 to 44. The program will scan the X value is which one? If for the P2, then this one, IOM, will become 2. The input index 2 will become 1. And another DIM arrow become 1. We have 2 because we use arrow to activate the P2 test A.cc. So this is a very standard example to control the input. That means to activate the instruction of the station. Okay. Let's continue to see each other until the last one, status 9. Another example for I/O, we know the K equal to 6. If this is a water jet, then we can see how the system handling the I/O. The first line, we use MCC get error codes to see any wrong in the control car. If something wrong, the program will mark the message. The message number is 30 to tell the main program to write the error message of 30. If nothing wrong, the program coding a clear error of the car. And the coding teach BFX this routine. Then calling MCC line. The most important for K equal to 6 is open water, open sand. We continue to see how to open water, how to open sand. After the motion instructions running out, the program will ask if the remove gun mode equal to 0, then we'll do the open water, open sand. If not 0, we not control the open water, open sand. That means for the 9 stations control, if 9 stations announce remove gun modes equivalent to 0, That means the station 9 not used as the water jet. The program will run inside this period. If remote gamma equal to 0, the program will continue to check. If P9 station equal to 9, if equal to 9, the program will ask CAPP mode equal to 0 and M code control equal to 0. This is according the need of the program. According to the I/O table, the output index 8 equal to 1. According to the I/O table, output 8 equal to 1 will push the relay to turn the water gun, to turn the head of the water jet, and the DO open 8. The DO open 8 written by Modbus will open the output delay 8. The PLC always has delay, so we sleep 1000 microsecond. That means for 1 second until the open index 8, the relay activated, finished turning. Then DOM 3 equal to 1. Open water. The same. Use DO open 3. Open the water. Turning, open water. And the program has a sleep time. After the defined sleep time, according to the I/O table, output 4 equal to 1. Output 4 equal to 1 according to the I/O table is set. Is to set to open the send. DO open 4. So this is I/O control by Modbus. The output 8, output 3, output 4, we have to check our I/O table. To open 8, to open 3, to open 4, the program will use Modbus to control Vertex PLC output, to control the 8th, the 3rd, the 4th relay, to lay the system, the head of a water jet, turning first, and open water and open sand. This is the main function of K6. The same for K10 is cross the water, cross sand. The parameter the same, but it's too short. shut 8 to shut 3 to shut 4. The multithread after teach status 9, if success, Microsoft will create teach status 9 as a single computer running inside the PC. So teach status 1 until teach status 9, the program inside Windows will open 9 threads, means 9 computers running together, 9 computers sharing the time with our main program. Actually, the system or some program running, more than hundreds program running, but for our control program, at least main program and teach status 1 until teach status 9, 10 programs chasing times each other. The Microsoft will handling smoothly. The i7 of the computer's CPU is very fast. We don't have to worry about too many programs to share the times. We'll delete the operating. The program still running fast as a rocket flying on the sky. Okay, the end of the demonstration.
烧出一幅天亮和地空。
真心的相爱，不怕火海来折磨，我们就是最美的景色。
我们的爱情就像点点的星火，你无时无刻不在温暖我。 熊的烈火，它烧出一幅天亮和地空。
真心的相爱，不怕火海来折磨，我们就是最美的景色。真心的相爱，不怕火海来折磨，我们就是最美。